All right, and we're back. Well, I hope that everything went well yesterday for you guys. Like I said, that was my first video ever, and after viewing it, I felt okay. I felt like I didn't sound like a complete idiot, and hopefully it made sense to you. And so what we're going to be moving on today is just kind of piggybacking on what we did yesterday. We have to be able to prove triangles congruent, but the figures and the complexities of the proofs continue to get more and more difficult. So it's very important that you focus in on exactly what the proof or the given is saying and know or have a plan to get to the final answer, which is the proof. And so as I look up here at the given, we're told that CA, this length right here, is congruent to CE over here, okay? And we're also told that BA, this length here, is congruent to DE, this length over here. And we're trying to prove BX congruent to DX. Now, the first thing that I really want you to concentrate on is trying to figure out which two triangles have both BX and DX that are whole sides of them. And I think if you look at the picture, the only two triangles that I can see that have both BX and DX that are whole sides of the triangle would be those two I just outlined right there. Those are the only two triangles that have BX and DX as a whole side. So ultimately, what we are going to be working towards within this proof will be proving those two triangles congruent to each other. And so I'm going to label the parts here: A, B, X, D, and E. Okay? And we know as of right now that AB is congruent to DE. So I'm going to go ahead and mark that congruent. Now, I would hope that you'd look up there and say, yeah, hey, look, vertical angles, that's awesome. I can prove that. But beyond that, there's nothing else I can prove from what we currently have. So as a result, you've got to take a step back and say, okay, with the given, what else could I possibly prove? It's kind of like if you do a white elephant gift at Christmas time. My aunt loves to give white elephant gifts, and a lot of times one of her favorite things to do is wrap up multiple presents in one box. I don't know if you have any family members that are like this, and they love to watch you have to unwrap all of them. Sometimes there's a present in all of them. Sometimes there's no presents until you get to the final one. And so it's kind of like that with this. You have this problem, and so you have to step back and look at the whole picture and work your way from the outside in. And so I'm going to redraw the whole big triangle here, this whole big triangle, and look at what we are given currently. And so I have C, A, and B, and I know that CA is congruent to, oh, that isn't B, that is E. Well, it's one of the problems of doing a movie. I can't go back and redo that part. Anyways, CA congruent to CE. Now, I hope that you guys are sitting there thinking, yeah, I've got an isosceles triangle. So what do I know about isosceles triangle? Well, the other day, we talked about how these sides being congruent would make these angles congruent. So sometimes in a proof, you don't know the direction that you're heading exactly, but it's good to just state some things to get it out there. I will say this, that if on your test, and there's a lengthy proof, if you don't know the final answer, how to get to the final answer, give me everything that you do know to be true. Don't state something that's incorrect. State only true things, but as long as you're giving me true things, some of those true things might lead to your final answer. And so I'm going to write up here in number 2 that angle, and I'm going to put angle, let's say angle CAE is congruent to angle CEA by the isosceles triangle theorem. Okay, the isosceles triangle theorem. So I can mark this angle congruent to that angle. Now, with what we already know, in that this segment is congruent to this segment, and that this angle here is congruent to this angle here, which triangles do we know the most about? Well, I'm going to highlight this for you if you can't see that very well. This segment, and this angle, and this angle. Okay? Now I hope that you can see that knowing this segment and this angle, or this segment and this angle, you know a lot about this triangle right here. And also this triangle right here. Okay? So what I'm going to do, I'm going to get rid of those markings there over here. And I'm going to go ahead and take that triangle and remove it. If I can. There we go. Okay. And do the same thing with the other triangle. Okay. Now, if I label the vertices here, A, B, and E, congruent and congruent based off what we've proven or have been given to us so far, and then A, E, and D, congruent, congruent, okay? My next question would be this, what else can we mark congruent that isn't marked congruent already? Well, again, we have those overlapping parts. This segment here is the same as this segment here. So we mark it congruent and congruent. And so I'm going to go ahead and say AE is congruent to AE by the reflexive property. Okay. Now, like usual, do we have congruent triangles? And the answer is yes. Okay, so I'm going to go ahead and write down the triangles are congruent. ABE is congruent to triangle EDA by side angle side. Okay. Now what we want to do is we want to go ahead and figure out what parts from this triangle, I'll just focus in on this one right here, are also parts of this triangle up here. Now if it helps, I'm going to go ahead and use different colors here, and let's try, I'm going to make this a little bit larger, see if that will work. If I go ahead and highlight that triangle right there, that's the one we proved congruent with the other triangle of its same size. And then I'm going to highlight with a different color here this triangle, which we want to eventually prove congruent. Okay? Are there any parts from both of those triangles that are the same, that are shared? All right? Now I would hope that you would see that DE is the same in both those triangles. Okay? That's the easy part. But are there any other parts? And the answer is yes. If you look at this angle right here, this angle at D, it's the same angle in the big triangle as it is in the small triangle. So as a result, I can go ahead and state that those two angles are congruent because they correspond, like we talked about last Friday. And then from there, we can hopefully build a proof to prove the other two triangles up here congruent to each other. So, with that being said, let me, I'll leave that there for right now. Okay. So number 5, I'm going to go ahead and say that angle EDA is congruent to angle ABE. Okay? And again, that's going to be by CP/CTC. All right? Corresponding parts of congruent triangles are congruent. And I'm going to take those congruent angles. You can mark them down here if you want. But I'm going to take those two angles and I'm going to put them up here. All right? And now things start to look good for us. Okay? We talked at the beginning of this proof, we said, hey, I know I've got those congruent sides, I know I've got vertical angles, but it's not enough information. But now with those congruent sides and the corresponding angles that we just said are congruent, these two angles being vertical are congruent, so I'm going to add that right now. You could have put that up higher in your proof somewhere. It doesn't matter to me. I just think organizationally it looks better because they're part of the second triangle that we are proving congruent down here. So again, I'm not going to count you off for putting it up above. It just has to go before the second pair of triangles congruent. So I'm going to say angle AXB is congruent to angle EXD. All right, because vertical angles are congruent. Okay, and so if I mark those two angles congruent, do we have congruent triangles? Yes, we do. So I'm going to go ahead and say triangle AXB is congruent to triangle EXD. By angle, side. The last thing we're going to go ahead and do, since BX and DX are a part of those two triangles, we can go ahead and use that CP-CTC again, because again they are part of these two triangles. And so I'm going to go ahead and say that BX is congruent to DX by CP-CTC. And that is the entire proof. All right, now if any of that didn't make sense to you, I would encourage you to rewind it and watch it again or parts of it again. And if it still makes sense to you, maybe ask a neighbor. Okay, and that's completely fine with me. All right, so just to review, what's the important thing to do when we're doing these more complex proofs? Well, it's very important to identify which two triangles you probably want to prove congruent to each other. That's number one. Number two, if you cannot directly prove those two triangles congruent to each other, you want to take a step back and see if there's any other information that would help lead you to proving another set of triangles congruent. Okay? All right, so hey, wake up. We got one more proof to do. Turn your paper over to the back side. And let's take a look at this proof. All right, now in this proof, we have marked out here the given already. The angle at C and E are congruent. These two angles at A are congruent to each other. And what we're trying to prove is that the segment of BD and the segment of FD are going to be the exact same length. Now, unlike the last problem, where we actually could figure out from the beginning which two triangles we're working towards proving congruent, this one it's not possible to do that. And here's why. If you notice here, these two segments are actually in the two smaller triangles, but they're also in these two medium-sized triangles. And so we don't know right now. We're kind of stuck in trying to figure out which two triangles we will eventually want to prove congruent. But if you notice, with the two angles that are proven congruent already, that are given to us, that leads us to proving two of the two bigger triangles congruent to each other. And if you notice, as I'm going to outline here, this triangle here and this triangle here, we know quite a bit of information about already. All right, and so I'm going to go ahead and pull those two out of the picture there and label their vertices and the given, and ask you guys, what would you do from there? All right. Now again, I think most of you are really good with this, and so you're probably thinking the reflexive property, and that's a good thing. So I'm going to go ahead and write that down, that AD is going to be congruent to AD by the reflexive property. All right. Now from there, if you look, man, that works out nice because we already have congruent triangles. I know that ADC will have to be congruent to triangle ADE by angle side. And again, remember, the side's not between the two congruent angles. That's angle side, as opposed to when it is between the two congruent angles, which is angle side angle. Now from there, what you need to do is, and I'm going to actually, I don't know if I can push this back up. See if I can push it back up. Can I take the whole thing? No, I can't do that. All right. I'm going to go ahead and highlight the current triangles that we have just proven congruent. Make that with a bigger, okay, we've proven this triangle. And we'll just focus on that. We know it's the other triangle as well, but let's just focus on that. And what we want to do is ask ourselves, which of these two triangles could we borrow pieces from this triangle to prove either of these two congruent? Okay, and so I know that's kind of leaving it wide open, but let's break this down. We already know that this segment's congruent to itself. So you might be thinking that, hey, this one we know more about. We know the angle here and the side there, and that's good, but here's the problem. This side right here, it isn't a part of the big triangle, which is fine, okay? This side right here, AB, is not a part of the big triangle. I know it's a part of, but it's not an entire part. And so if you want to use CP-CTC, this is very, very important. You need an entire part, okay? As I look, this angle right here is not an entire part of a triangle that would use these two segments. And so that only leaves one option. This segment right here is an entire part of both the big triangle and this small triangle as well, with BD as a part of it. Okay? And so I know that may have been kind of wordy there, but what I want you to see is that this segment is not only in both the big triangle right here, but it's also in the small triangle, which includes this segment, which we need to prove congruent. And so I'm going to go ahead and trace around these two triangles, and I'm going to pull that out. Okay, and we're going to look at that together. Maybe we'll do it down here. Okay. So if I go ahead and identify this as B, C, D, E, and F, okay? And I'm going to mark the angle at C congruent to the angle at E, and I'm going to mark CD congruent to DF, all right? Because they're corresponding parts of the congruent triangles we proved before. So for number 4, I'm going to say CD is congruent to DE by CP-CTC. Corresponding parts of congruent triangles are congruent. From there, if you ask yourself what other parts from these two triangles can I mark congruent that isn't already congruent, I would hope that you really quickly see the vertical angles there. Angle BDC is congruent to angle FDE. Okay, and as I mark those two vertical angles congruent, okay, you see that we have congruent triangles. Think to yourself, what reason would it be? It would be angle, side angle. So I'm going to write down triangle BCD is congruent to triangle FED by angle side angle. And the last step, since the triangles are congruent, we know that these corresponding parts have to be congruent. So I'm going to write BD is congruent to FD by CPCTC. Okay? All right, so here's what I really want you to take away from this one. When you are borrowing parts from bigger triangles, like these two right here, to prove another set of triangles congruent, it's got to be an entire side. Okay? It can't be a portion of a side because that's not really a part of the big triangle. And it's got to be an entire angle, so to speak. In this case, this angle here wouldn't have been in either of those other two triangles, so it's irrelevant. And so I hope that was a pretty good explanation there. What I want you to do for tomorrow, or for Monday, is page 228, 17, 18, 27, 28, and 33. Now, all of those but one will be written as a two-column proof, and the one that will not be written as a two-column proof is going to be the one that's the flow proof, and I'll comment on that in just a second. So, might want to pause there and go ahead and jot that down. But I'm going to go ahead and pull up the homework because there's some things I want to give you as pointers as you work through this, because I know this can be a little complicated. And so I'm going to go ahead and pull up the textbook here. All right, so here I'm at the textbook, and as I said before, you're going to be doing two-column proofs for most of these. The first one, number 17, you can see the given and the proved there. I'm going to give you, you may want to pause here and ask yourself which two triangles you're going to want to prove congruent first. And so press pause, and then I'll give you a hint. All right, now we know that we're trying to prove triangle QET and QEU congruent to each other, but before you can prove those two triangles congruent to each other, you are going to have to prove triangle QTB congruent to triangle QUB, because those are the two triangles we know the most about currently. We know the two angles here and the two angles here. Within that, those two triangles are congruent. That's why you'd choose those two triangles. Okay? For number 18, you're also going to be writing a two-column proof for that one. And if we look there, we've got the AD congruent to ED, and we know D is the midpoint of BF. And we want to prove ADC congruent to EDG. Okay, so that's the final pair of triangles that you want to prove congruent. In order to get to that point, you are going to have to prove these two triangles congruent. Again, I'd pause your computer there for a quick second and ask yourself, which two triangles do we know the most information about? That would be the easiest to prove congruent. Okay, so again, pause it for a quick second there. All right, the two triangles that you're going to prove congruent first in this picture, this problem, this two-column proof, will be triangle EDF and triangle ADB. Okay? Once you have those two triangles congruent, you can borrow parts from those two triangles that will be a part of the bigger two triangles that you're trying to prove congruent there. Uh, 27, as you can see, is a flow proof. And so no need to do a two-column proof for this one. You can just go ahead and fill in the unknowns there. Again, I would encourage you to draw whatever triangles you believe you're trying to prove congruent to first, separate. I think visually it helps you see things. And so I would do that as you're doing number 27. 28 obviously is already set up for you. You just have to fill in the unknowns. And so go ahead and do that with that one as well. No need to set up your own 2-column proof with that. Okay, for the last one, number 33, and probably the most challenging one, I would encourage you, again, to look at the given here and ask yourself what you can actually mark out from the given. And I would actually draw it on my piece of paper and mark those things. And I'd pause it and see if you can figure out which 2 triangles you want to prove congruent first. Okay? Now, the 2 triangles you actually want to prove congruent first, because QT is perpendicular to PR, would be, and the fact that, let's see here, QT bisects PR, would be these 2 triangles here, PQT and RQT, those 2 bigger triangles right there. You want to try to prove congruent first. So I'll write that down. First prove triangle PQT congruent to triangle RQT. And then second, the second time you're going to prove, because as you notice up here, right there, VQ is congruent to SQ. Well, those are segments. They're not actually triangles like we saw in our proofs. So in order to get to that point, I'm going to look at these 2 triangles here based off what I'm given. This part right here really tells me that I'm going to be working with these 2 triangles here. Okay? And so after proving those 2 triangles congruent, you're going to borrow parts from those 2 congruent triangles to go ahead and prove these 2 triangles, triangle VQT and triangle SQT congruent. So good luck with those proofs. You know, those are some good ones, and I like them a lot. And so you can expect to see something like that, maybe even just a little more complicated on your test. And so good luck on the homework. I hope you have a wonderful weekend, and I look forward to seeing you guys when I come back on Monday. So have a great weekend. Bye.